Who is missing now? Ashish. Then Sana didn't join today. Yeah, we didn't see Sana today. Hmm. Okay, we'll start the class. Yes, so where did we reach? We started the nervous system. We divided it into two, the central and the peripheral nervous system. Then we saw the divisions of the peripheral nervous system first. What are the divisions, Greshma? Divisions of the peripheral nervous system. Greshma, can you hear me? Do you know the divisions? I think she can't hear. Who can tell me?
Autonomic and somatic.
Yeah, autonomic and somatic. Then, what did we learn in? Yes, Sana is here. What did we learn in autonomic and somatic, Meghna?
We learned the somatic nervous system. There are 12 sets of cranial nerves, and it impulses originating from the brain to muscles. And in autonomic nervous system, we studied it controls the internal functions as breathing, heart rate, etc.
Okay, apart
And
from nerves, what are
that we
the
have
nerves
section.
in somatic?
Sensory.
No, that are the types. The cranial nerves and another set of nerves are there. Cranial nerves related to brain and so helping the part in the central nervous system, that is the regarding the brain. We have some other thing in the central nervous system, right? Brain,
Mixed.
spinal cord. So the cranial nerves would assist the brain, and what nerves would assist the spinal cord? The spinal nerve. Okay. Yes.
Yes, ma'am.
Okay. So we studied about the different divisions of the brain in today's class and different structures. We divided into hindbrain, midbrain, and forebrain. And we have been discussing about forebrain towards the end of last class. Now we reached the cerebrum. Cerebrum forms the most of the part or the majority part of the brain. Yes, Sana, are you all right? Didn't see you today. Okay. We are kind of finishing the structures of the brain. This is the last structure that we are going to study. And tomorrow we'll finish the CNS. That is, we'll study about the spinal cord also tomorrow. And probably we'd start the endocrine glands. Okay. Sana, go through the portions, okay? Yes. So coming back to cerebrum, the majority part, that is the bluish color that you see, that is the cerebrum as such. Then also known as cerebral cortex, this part regulates all higher levels of cognitive functions such as attention, perception, learning, memory, language, behavior, reasoning, and problem solving. Yes, attention, basically what things you notice, what you attend to, how long do you sustain your attention, all those things. Then perception, how you understand and interpret things. Then learning, how you keep on learning new things with new experiences in life. Then memory, how you usually store information, how you can recall information. Then the language behavior, how can you communicate, whichever languages you can use. Then reasoning. Reasoning is deciding based on critical thinking, based on logical reasoning or logical, how you decide what is logical, what is illogical. You give reasons, you find causes. Then we have problem solving, which is the um, along with the reasoning thing, you also do problem solving. You try to find different solutions for different problems that you encounter. All these functions, cognitive functions are mainly regulated at very higher levels or in a very complicated fashion by the cerebrum, also known as the cerebral cortex. Okay. The cerebrum makes two-thirds of the total mass of the human brain. So only the one-third portion is left for the other structures and other small parts of the brain. The two-third portion, like if we divide the brain into three parts, then the two-third portion is filled or the covered by the cerebral cortex or the cerebrum. Its thickness varies from 1.5 mm to 4 mm, which covers the entire surface of the brain and contains neurons, neural nets, and bundles of axons. Bundles of axons are otherwise called? Yes? Yes?
Neurons.
No. We have axon as the elongated part, and bundles of axons are otherwise called? I'll give a clue. We have sensory, motor, and mixed type of that particular thing.
Nerve.
Nerves. Yes, bundles of axons are called nerves. All these make it possible for us to perform organized actions and create images, symbols, associations, and memories. So probably all these functions, all the cognitive functions are mainly dealt with by the cerebrum or the cerebral cortex. And the cerebrum as such, it has lots of networks of neurons, the nerves, then the bundles of axon, that is the nerves, and neural nets, that is small structures found by these neural connections. All these things together perform the whole functions. It helps to organize things, organize our actions and behaviors, then coordinate different movements, then create images, symbols, associations, and also memories. And we are going to learn about the two hemispheres. Are you familiar with this? The two hemispheres of the brain. Have you studied in science? Yes. Okay. Which are the two hemispheres, Amal? Which are the two hemispheres of the brain?
Ma'am, my right hemisphere left.
Right hemisphere and left hemisphere. Yes. And we can tell that the brain is divided into two equal halves based on the left and right side. So obviously they become the left and right hemispheres of the brain. And this is one angle. From another angle from the front part, it would look probably like this. Okay. And yes, this you don't have to study much, but you have the left brain and right brain dominance thing, right? If left brain is dominant, then you're very good in mathematics, the language things, science, and Yes, can you see the video? Yes? Can you see the presentation?
Yes, ma'am.
Okay. Sorry, we had a power failure just now. Yes, we are talking about the left and right hemispheres of the brain. So usually it is considered that the left side of the brain or the left hemisphere of the brain controls the which side of the body? Do you know anybody?
Right.
Right side of the body. So if something happens to the left hemisphere of your brain, then it will affect the right side of your body, the whole body. Okay. And if the left hemisphere is damaged, then probably your right side of the body is supposed to go paralyzed or something. Yes. And similarly, vice versa. If something happens or if any damage happens to the right side of your brain, then it affects the left side of your body. Understood? That is how it is. And usually, for those who have the left brain as dominant, they probably has these characteristics, or they are good in these things. Which are they? The thinking in words, that is more they have more abilities in handling languages. They think in words, they think in different languages. They, I mean, which language do you think? Have you ever thought about it? Yes? No? Which language do you think in? Yes, who can tell me? Meghna, have you thought about it?
No.
No. Anybody who has thought about it? Like when you think of your past or when you think of your future, which language do you think in? You think in English or in your mother tongue or in any foreign language?
Mother
Yes?
tongue.
Any idea? Even I didn't think of it until I started learning cognitive psychology during my PG days. My teacher asked the same question to me, and I was like, yeah, why didn't I even think about this earlier? You think about it and you observe yourself for one day, and tomorrow you come and tell me which language do you usually think in. Okay. And then sequencing. For those who have the left brain as dominant, they would be good in sequencing. That is, in organizing things, in putting everything into series. Yes, that abilities are there. Then linear thinking happens. That is straight away thinking, direct thinking. Not in different ways, but straight thinking. A leads to B or B leads to C. Such type of thinking process would be more dominant in these people. Then they would be probably good in mathematics, science, then facts, then logical thinking. Logical thinking would be higher in people who have left brain as the, or the left hemisphere as the dominant one. Then for the right brain, the most probably we call it the artistic brain, the artistic side of the person. The feelings visualization, they visualize feelings. Like if they are feeling happy or sad, they imagine themselves. Like in future, uh, normally we ask people, where do you see yourself after 5 years? Or where do you see yourself after some 10 years? Then they would probably imagine it, imagine the situation or the scenario in different vivid images, different artistic ways in their own fantasy world, right? Hmm? So for such people, they visualize their feelings, then imagination, that would be very high in these people. Then intuition, they would always have their gut feeling. Haven't you heard about the gut feeling? They won't think much about it. They have this intuition in themselves and they try to go with their gut feelings. Okay. And the other part we saw in the, for the people who are dominant with the left hemisphere, they just give so many logical reasons, they think in so many ways, and then they come at a solution. But these people, when they hear a question, they have a gut feeling and they give the spontaneous answers. Understood? That is the intuitive the intuitive feelings or the intuition. Then rhythm, they'll be so much attracted towards rhythm. They'll have abilities to follow the rhythms also. Then they have a holistic thinking. There we saw the linear thinking, that is direct thinking. Holistic thinking means they can see multiple perspectives for everything. They see the whole thing, which is the school of psychology that deals with the holism. Anybody? What psychology did we learn? Whole is better than the sum of its parts. Yes. Anybody? Start.
You just told.
Yes, gestalt psychology. Very good. Okay, that is about holistic thinking. That is thinking the anything that they see it in multiple perspectives. They take it into a whole and consider each and every elements. Yes. Then they'll be good in arts. They'll be very good artists. Like in abstract paintings. Have you noticed abstract paintings? What the person intended might not be the thing that we understood, right? And some people, they fail to understand what the picture really means. And people like me would think, what nonsense is this? Like after seeing an abstract image, yeah, they have thrown in different colors and they have made something which we won't, oh, at least some people won't understand. Okay, that's about left and right brain. Then we have the notes. Yes, the cerebrum is divided into two symmetrical halves called the cerebral hemispheres. Although the two hemispheres appear identical, functionally one hemisphere usually dominates the other. So, in human body, we have a brain and we have two hemispheres for it. That is the left and right hemispheres. They look identical, but the thing is, as we mentioned in the last slide, one hemisphere might be dominant in most of the humans. But we may also have both these artistic as well as mathematical skills. But the thing is, one hemisphere would stand out prominently, or it would be dominant in humans. That is how it is. But both of the hemispheres function together, but for a particular purpose, one hemisphere will be always dominant. Then, for example, the left hemisphere usually controls language behavior. The right hemisphere is usually specialized to deal with messages, relationships, and pattern recognition. So left hemisphere, L, learn that connecting to the L, the language. Okay, language, and with language comes the logical thinking, another L. And logical thinking, of course, we need that in mathematics and science and all those subjects. So connect it and learn it like that. Okay, left hemisphere means language, L, L. Okay, yes. Hemisphere, the mathematics, the language, the communication, thinking in words. Then, so that comes along with the logical thinking, the critical thinking, critical reasoning. Then that would be necessary for mathematical skills, scientific skills, facts, and things like that. So the right hemisphere would be entirely different from it, the artistic part, the pattern recognition, to play with colors, then imaginative thinking, fantasy thinking, intuitive thinking, all those things comes in the right hemisphere. These two hemispheres are connected by a white bundle of myelinated fibers called corpus callosum that carries messages back and forth between the hemispheres. So if I take a cross section of the brain like this, then we'll get the left and right hemispheres, right? But we need a connection for it. These are two parts actually. They are divided into the left and right hemisphere, but we need a connection. That connection is known as the corpus callosum. Note that in your lecture note, corpus callosum. And it can be said that this particular corpus callosum acts as a bridge between the two hemispheres. Okay, and what is this corpus callosum made of is a white bundle of myelinated fibers. Myelinated fibers, I hope you are familiar with the myelin sheath that we learned when we learned about the neuron. The myelin sheath, yes? Have you heard about it?
Yes, ma'am.
Okay. Myelinated sheath, they are the insulations we have on the axon. On the axon part of the neuron, we have the insulations, and they are the myelin sheath. These myelin sheath, when we look from a distance, we have these fibers, the neuron fibers, as myelinated. It will look insulated in nature, and the bundle of these myelinated fibers, we have a cluster of these bundles in the corpus callosum. Understood. So these myelinated fibers, the bundle of myelinated fibers together form a cluster, and they form a structure called corpus callosum, which acts as a bridge or a connection between the left and right hemispheres. Understood? So we can't just leave the left hand hemisphere loosely, right? They need to coordinate different functions. If this has to do mathematics, then this has to do artistic. But there are times when we have to involve both these things, like in your integrated art projects. You need both of these together, right? So if this corpus callosum is not there, then probably either you can do only the mathematics, or either you can do only the artistic things. If you want to put both of these together, then you need a connection. So that connection is made by the corpus callosum, which is a bundle of myelinated fibers. Understood? Yes. So this carries the messages or the information back and forth between the hemispheres. So from the left hemisphere, the information would be sent to the right hemisphere, and similarly, the right hemisphere's information or the messages would be sent, or it will be linked to the left hemisphere by the corpus callosum. Yes. Clear? Okay. Now, this is the corpus callosum. So again, if I do a section like this, then we have one hemisphere on one side, and in the middle we have the greenish part called the corpus callosum. Okay. And what is this cauliflower-like structure called? I should keep quiet. Let me ask somebody else. Who would tell me? Elvina. What is that structure called?
Then that green color part?
The green color part. This cauliflower-like structure towards the part. Wrinkled surfaces, which helps in coordination, which helps in maintaining balance, which helps you.
Cerebellum.
Very good. Then, yes. So that's about the left and right hemispheres. Now we are going to study about the lobes of the brain. Okay. Next topic is lobes of the brain. I just introduced lobes of the brain when we studied about the occipital lobe. We studied that as an example, and I told you we'll be learning that in our third chapter. So in this topic, we'll be learning about the 4 lobes of the brain. Okay. So namely, the 4 lobes are frontal lobe, parietal lobe, temporal lobe, and occipital lobe. Note the names: the frontal lobe, the parietal lobe, the temporal lobe, and occipital lobe. I show you the picture and we'll come back. Yes. So the most of the portion, the bigger part forms the frontal lobe. Then the yellowish color that we have is the parietal lobe. It will be on this part. Then towards the back we have the occipital lobe, and on the 2 sides we have the temporal lobe. So coming back to the frontal lobe, the frontal lobe is mainly concerned with cognitive functions such as attention, thinking, memory, learning, and reasoning. But it also exerts inhibitory effects on autonomic and emotional responses. So do you remember the case study about Phineas Gage? Yes? Phineas Gage, who had a crowbar going through his left cheek and coming out of his skull. Yes? Yes, okay. So what happened is, for him, the major part of the brain that was affected was the frontal lobe. And that's why his personality and certain thinking abilities drastically changed after that accident. Okay, so what all does this frontal lobe help in? The cognitive functions, that is attention. Attention, I already told you, that is how long can you notice a particular stimuli, how long can you sustain your attention, how many items can you attend to. Then the basic thinking skills, then memory, that is storage, encoding and retrieval of information. Then learning, how you learn things with your experiences, different experiences in your life. Then reasoning, have you reasoned what is good for you, what is not good for you. You engage in critical thinking. You have to understand what all things have to be done to do this, what causes what. All those things are dealt with in reasoning. But it also exerts inhibitory effects on autonomic and emotional responses. Yeah, frontal lobe, it has it not only helps in all these cognitive functions, but it also has an inhibitory effect on autonomic as well as emotional responses. I told you during the Phineas Gage, when we discussed the Phineas Gage case study, his emotional responses, his inhibitory responses, his behaviors totally changed, his personality totally changed after the accident. Like his colleagues and his family members started to tell that this is not the Phineas who was before the accident. Right, do you remember me telling that? Yes. So that is because he got the major portion of the damage was caused to the frontal lobe of his brain. Okay, that's about frontal lobe. Now, the parietal lobe. That is, the parietal lobe is here. It has boundaries with all the other three lobes. In back part of the frontal lobe, it comes in the front part of the occipital lobe, and it is surrounded by the temporal lobes on the side. Yes, the parietal lobe is mainly concerned with cutaneous sensations and their coordination with visual and auditory sensations. So imagine somebody comes and you were sitting and writing something, and somebody comes and gives you a huge pat on your back, and it was quite painful. Okay, have you seen the movie Kali?
Yes, ma'am.
In that, Dulkar reacts to the frequent pats from Saubin, right? Yeah, that is cutaneous sensation. Cutaneous sensation means the sense of touch. Mainly deals with the sense of touch. It also has also deals with the sensation of pain. Okay, so cutaneous sensations and the coordination with visual and auditory sensation. So when he gets a pat, he realizes who he turns and looks who gave the pat, and he realizes that it is a person, it is his colleague, and the visual and auditory sensation, that is the dialogues that the other person is telling, he is able to hear it, he is able to sense it. So all these things are dealt with by the parietal lobe, that is concerned with the cutaneous sensation, and then coordinates with the visual as well as the auditory sensation. Okay, that is all about the parietal lobe. Then the temporal lobe. Temporal lobe is primarily concerned with the processing of auditory information. It is found near the ears on two sides. Okay, so basically it will deal with the auditory sensation or the auditory information. And it mainly it is concerned with the processing of the auditory information. Any sounds that you hear, any speech that you hear, all these things are processed mainly with the help of the temporal lobe. Memory for symbolic sounds and words resides here. Symbolic sounds means, yes, if I ask you, do you want ice cream? In Malayalam, you would say, ah, right? And what does that ah mean? Yes. Yes. Yes or no?
Yes.
Okay, so that is a symbolic sound. I just made a sound ah, and that is a symbolic sound which symbolizes yes. Okay, and if I ask you, do you want to attend 5 hours of mathematics class along with me? You would probably say mm-hmm, right? That is a sound, mm-hmm, and that represents a no from your side. So that is again a symbolic sound. So the memory for these sounds. So if the temporal lobe is not working properly, then you forget this and what this and would suggest. if you have to remember it, then you need this temporal lobe. So the memory for these symbolic sounds and words are mainly residing in the temporal lobe. Understood? So the main function is regarding the auditory information, processing the auditory information, because it's present near the ears, connected like that. Okay, it is present near the ears, so it would be probably dealing with the auditory information, the processing of auditory information. Along with that, the memory for the symbolic sounds and words, that also is included there. Then understanding of speech and written language depends on this loop. Of course, the speech that we we hear, or the words that in written language, if we see it, then that also, the processing of that information also, we need the temporal lobe. Okay, that is about the temporal lobe. And then we have the occipital lobe. It is mainly concerned with visual information. It is believed that interpretation of visual impulses, memory for visual stimuli, and color visual orientation is performed by this particular lobe. So temporal lobe was about the auditory information. Occipital lobe is about the visual information. Okay, occipital lobe is present behind our head. And when we take a section like this, it's just behind our eyes, right? So occipital means connected with the eyes, that is the visual information. And it is believed that interpretation of visual impulses, memory for visual stimuli, and color visual orientation is performed by this lobe. Interpretation of visual impulses means whatever visual stimuli we see, we have to understand that it is this. We have to interpret it. So interpretation of visual stimuli would be dealt with by the occipital lobe. Then memory for visual stimuli, that is in the temporal lobe we had memories for the sounds, right? Symbolic sounds and words. Here we have memory for the visual stimuli. Okay, the visual things, anything that you see, if you want to memorize it, then you need the occipital lobe. Okay, and color visual orientation is performed by this lobe. Color visual orientation means when you see something, you have to orient its color, right? Let us organize different colors that you see, or recognize the color, which color it is, and have memory for this color. All those things are dealt with by the occipital lobe. So again, revising it a little bit, that is the four lobes of the brain, the frontal lobe, the parietal lobe, the temporal lobe, and the occipital lobe. Frontal lobe is concerned with mainly the major cognitive functions. Then parietal lobe is concerned with the cutaneous sensation and coordination with visual and auditory sensations. Then temporal lobe, mainly auditory function. And then it has memory for symbolic sounds and written language, speech, then the symbolic words. Then occipital lobe, mainly concerned with processing the visual information, and memory for visual stimuli or visual impulses are also dealt with by this lobe. So that's about the brain structures. We have finished the brain structures. Tomorrow we have the spinal cord left in the CNS. That's it. Any doubts? Any doubt? Too much of terms to learn, so start learning. And we'll start, wait a minute.